Okay, so what we're going to have to do now is show off our low-level programming knowledge, or lack of, so to speak. We'll find out. Pause the video, see if you can actually fill this out yourself first. I'm not expecting you to be able to do this by yourself, but it's worth a go just to put it out there. You need to be using the opcodes from the table on my left, so here, these opcodes, and the operands would be basically different variables which we're going to be using from down here and here when necessary. Okay, I'm going to do a solution. The first thing it wants us to do is load the value from answer. So we know that we want to load something up, contents of a location at a given address called answer, and we're going to put it into the accumulator. So we're going to use LDD answer. So let's imagine we've got the number 4 inside answer. Well, actually, let's do 8. So we've got something called answer. Actually, it's 0 in this situation, so let's just use that. So we're putting 0 into the accumulator. So I'm going to do a little box up here for accumulator, and inside of it, we're going to put 0. It then wants us to add the value from num1. So to add a value to something, we need to use add as our command. I should say add, I just can't write. And the operand would be num1, so we're going to add num1 to whatever's in there. Num1 is 2, so we're now going to make the accumulator 2. Then, whenever we make a change to our accumulator, we now want to store the result, and we're going to store it in answer. So answer is going to now become 2. So it takes it from the accumulator and it dumps it into this memory space there. So this is a tip. Every time we load and we do something in the accumulator, add or increment, we then need to store the results of that into a memory address. So it goes back into answer, so we've updated it. The next thing we want to do is load the value from count. So again, we're going to use LDD, because we know it's going to be loading, and we're going to be loading it from count. It now wants us to increment the accumulator. To increment the accumulator, it's going to be INC to increment, and we're going to be doing ACC there, which stands for accumulator. So that's basically going to take the 2, and it's going to make it, actually first of all it loaded count, so count would be 0, my bad. So it would have been 0. We then incremented the accumulator, which basically now means we're dealing with 1. Remember what I said? Whenever we make a change to the accumulator, we need to store that result. So we're going to store that result into count. So count is now going to become 1. We've now got this if statement. Is num2 equal to count? So I'm going to look over here on my different opcodes and let's see if we've got anything. Well, the if statement is going to be compare. So we're going to use a compare. So I'm going to do CMP. And it's going to be simply compare, and it's going to be num2. Now, if false, so if the result is false, jump to loop. So this is easy. I'm going to find jump as an instruction. We've got a jump here and we've got a jump here. This is for true, this is for false. So we need to use the false one, so JPN. JPN false. And we want to jump to the loop. Then what we want to do is load the value from answer. So LDD again, answer. It then wants us to output the answer to the screen. So if output, if we find on here, is OUT for output. And we're going to output. Now, I don't need to put anything in here. I can do output answer, but that's not what I need to do. Because we're going to output what's in the accumulator, which is answer, and answer is 2. So I can leave it blank like that. That's basically saying print what's inside my accumulator. Finally, to end, I'm just going to put end, and that is it. We are done. This is what it would look like at the end. Let's do another one. Pause the video, give this question a go yourself first. We've got the table here, we've got this information here, and we've got a scenario here. Do you read the scenario? Pause the video, give this a go yourself first, and see how you get on. This is a different scenario, keep that in mind. I have actually lost my mouse as well, which is really annoying. I don't know why. Anyway, pause the video, give it a go yourself first. Okay, so the first thing we want to do is input. So it's going to be IN for input. So it's going to let me input a character. That's all I need to do here. Once I input it, so I'm going to type in like A. I want to store that, and I want to store it in char1. So to store, it'll be STO. And I'm going to store it in char1. The next thing we want to do is input another character, so it's going to be in again. This time we're going to store it in char2. We then want to initialize the accumulator. Okay, so we initialize the accumulator to ASCII value of char1. So this is basically me saying we want to take char1 and put it into the accumulator. And to do that, we're going to use direct addressing. We're going to load the contents and put it into the accumulator. So it'll be LDD. Oops, I forgot STO here. LDD, and it'll be char1. The next thing we want to do is we want to output. Now, here's the thing. So the next thing we're going to do is compare the accumulator with char2. So that's going to be simple. CMP char2. We then, if equal, jump to the end of the for loop. Interesting. So it wants us to jump to the end, which is here. So we know that there's going to be a loop somewhere. If equal, so if equal is true, which one talks about if equals true? It's this one, JPE. So we're going to do JPE, and we're going to jump to this label, end for. Otherwise, we want to increment the accumulator, so inc the accumulator. In this situation, it tells us to jump to loop, so we're going to do JMP, which is jump, and we're going to jump to a specific address, which in this case is loop. Now, here's the thing. We don't know what is going to be looped, but we do know we want to loop from here. How do we know that we want to loop from here? Well, we know that we want to output the contents of the accumulator. We know that needs to happen. We know, based on this, it wants to compare the accumulator with char2. So whatever we've got in the accumulator, compare it with char2. So the accumulator, whatever value that is to start off with, we're going to compare that with char2. If it matches char2, we're done. If it doesn't match, we're going to increment the accumulator, and we're going to loop again. So what this is simply going to do is the following. So if you play this through, the first thing we enter is B. That's our first thing. The second thing we enter is F. We then load in our B again, which will give it the ASCII value. So let's imagine the ASCII value is, I'm just going to make this up, it's going to be 2. It will then output B. So on our screen we're going to have B. It's then going to increment, well, it's going to check, does whatever we've got in our accumulator equal char2, which is F. So B is 2, C is 3, D is D is 4, E is 5. So F is 5 in my made up ASCII values. So it's going to say, is it 5 yet? No, it's not 5. So we're going to increment the accumulator and we're going to output the next one, which is going to be C. It's going to then compare it. Does it equal 5 yet? No, it doesn't. It's going to increment the accumulator, it's going to loop again, it's going to output the next one, which is D, and it's going to keep going until we get to F, and then it's going to stop. So this is in our loop. How do I know this? Well, it tells us down here what's going on. Outputs the alphabetical order of sequence characters from the first to the second. So if the characters are B and F, it's going to output B, C, D, E, F. That's what this is doing. So it needs to repeat itself. We know we need to use a loop because it tells us loop. We know that it's going to be a for loop, so it says end for here. So the question is, where does it start? Well, we don't want to start the loop any higher than here. We don't want to start the loop any lower than output, otherwise we're not going to output anything when it repeats. So this is the place for it to start on the output. Pause the video, give this a go yourself first. Okay, you'll notice that we're using LDM this time, not LDD. That is because we're loading up basically a number to the accumulator. It will be the ASCII value of the question mark. Previously when we did LDD, it was like LDD from like score, from a variable, from a memory location. So whenever we're doing it from like a direct location of a given address, we use LDD. LDM is going to be used to load a number X into the accumulator. In this respect, we're loading in hashtag 63. We now want to output the question mark. So that's easy. We're just going to do out. We're going to output whatever's in the accumulator. That's it. We're now going to input. So we're going to input a guess. But we don't need to put in guess in here. That's not how it works. We just input. The next thing we're going to do is compare with a stored letter. So we're going to compare what we've typed in with our letter to guess. So if we type in, I don't know, B, it's going to compare B with our stored letter of A. Do they match? If correct, so it's JPE. If true. If correct, go to guessed. So JPE, guessed. Otherwise, we want to, before we can increment the attempts, we need to load it into the accumulator. So we're going to load into the accumulator attempts, which is 0 to begin with. We've had 0 attempts. So our accumulator is going to have 0 in it. Then we want to increment the data in the accumulator. So that's now going to be 1. We then need to store the change back into attempts again. So we want to store attempts back into here. We now want to do a comparison and check. Is attempts equal 9? To do that, we can use our if statement, our comparison, and we're going to compare it. So if I find CMP, we can compare it with a number, or we can compare it with contents of an address. We're going to do this one with a number, which is hashtag 9. Does it match 9? If out of guesses, go to MP. So if true, we're out of guesses. So we've made 9 attempts. Jump to MP. Otherwise, jump to, so false, the start. Well, it's not really saying it's false, it's saying if this true isn't ran. So JP is if it's true, otherwise we're going to jump back to the start again. So we start back at here. And then we've got load into memory 42. And then we're going to output the asterisk and program. Done. Pause the video, give this a go yourself first. I'm not expecting you to get this completely right. So relax when I go through it, because these are new concepts we're going over again. Okay, so what we have is numbers. Numbers is an array. Keep that in mind, where we want to be starting position 0, then 1, then 2, then 3, then 4. It tells us that we want to initialize the index register. To initialize an index register, which is IX, we want to initialize it to be 0. That's what we mean by initialize, making it 0 to begin with. And we're going to be using LDR to do this. So immediate addressing, load the number 0 to the index register. IX is index register, so we're going to use LDR. It now wants us to load the value from numbers. So it's basically going to go to our array, numbers, go to position 0, and load 22. That's what it's going to want us to do. So we can't use LDD, because we're not using a variable memory address location, we're using an array using index addressing. So instead of LDD, we're going to be using LDX, which is index addressing. We're going to go to numbers, and we're going to take the contents of the index register, which is 0 to begin with. So it's going to get 22. So LDX numbers. So that's going to load up 22. And it's going to put it into our accumulator. The next thing we want to do is multiply 22 by 4. To multiply something, in this respect, we're going to have to use a binary shift to the left. That's how you multiply dividers to the right. So a simple binary shift to the left is what we need to do. And to multiply it by 4, we're going to actually move it 2 places to the left. So look, if we had a number like this, 1, 2, 4, 8, obviously this makes 3. If we move it, shift it to the left once, we're going to multiply it by 2. So we're going to have 0, 1, 1, 0, which will give us 6. If we go to the left again, it's going to be 1, 1, 0, 0. So it's going to be 12. So by us shifting 2 places to the left, it's gone from 3 to 12. In this respect, we want to multiply by 4, 22. So obviously it's going to be 88. So that's what is going to be the result. We then want to store this new number 88 in numbers, but we can't use STO because STO just puts into a given address. So we need to use STX instead. STX is going to do the same thing. It's going to go to position 0 in numbers, and we're going to put in to STX whatever's in the accumulator, which is now going to be 88. So 88 is put into here. That is what we've just done. We then want to increment the index register, so INC and IX. So now the index register is going to be on 1. We then want to increment count because we want to keep track of how many times we've looped through. We want to loop through 5 times. So to begin with, we're going to load. So we've got a count here as 0, so we need to put that into the accumulator, so LDD count. We then need to increment counts. Sorry, increment accumulator, my bad. And then we need to store back into count again. So now count is going to be 1. We're now going to compare, is count equal 5? So we're going to do CMP to compare, and then hashtag 5. We're then going to say if it's not 5, so JPN, we're going to go back to the start of our loop. But we haven't got a start of our loop yet. Well, we obviously do, and that is going to be this. This is going to be our start of our loop because it's going to load the next value from our array. Position 1, the index register, it's going to be 13. So it's going to loop here. It's then going to do the whole thing again, multiply it by 4, to store it in the array, increment the index register by 1, load count again, increment count, so count's going to become 2, store count, compare is it does equal 5, if not, reloop again, LDX numbers, which is going to be 46 for next time, because this is going to be 3. our index register, etc. Before you rush into this, pause the video, give it a go yourself first, think it through. Okay, so we're dealing with another array, this time being letters, where we've got all these values, where we want to find the letter X. So step 1, we're using LDR 0. The next thing we want to do is load letters, so it's going to be again LDX this time, because we're using index addressing for the array. Is letters equals to letter found, so we're going to use compare letter to find. If not, so that's going to be JPN for false. We want to jump to not found. We want to increment found. Found is 0, so we're going to first of all load that into the accumulator. So found is loaded in. We want to then increment the accumulator. We then want to store the result back into found again, as in we found the letter. When it's not found, so that's if we found the letter. If it's not found, we want to load count this time. We want to increment the accumulator and store the result into count. We want to check now to see if count equals 6, so go use CMP hashtag 6. If yes, go to end, so that's true, so we want to be using JPE, and we want to go to end P. We want to increment the index register, so go to inc to increment IX, which is index register. We looked at that last time, IX being index register. Go back to the beginning of the loop, so that's just going to be a normal jump, and we're just going to do loop. And there you go. That is done. It's got a loop in for us, it's got a not found there, our end there, our letters, easy. Pause the video, give us a go yourself first. Okay, easy. Initialize the index register. Whenever we initialize, well, we know we're going to use LDR, and we're going to do hashtag 0 to initialize. Oh, my feed is here. 1 second. Now what we want to do is load up the array, well, the first element from the array, so it's LDX values, which is the name of our array. We now want to divide by 8, so we're going to do a shift to the right. And it's going to be done 3 times to divide it by 8. If you're not sure what I'm talking about, go to the previous question. Store the new values back in, new value, so STX values. So we're going to store the new result into here, so that'll be gone, whatever it's going to be replaced with. Increment an index register, so INC, IX. Increment reps, LDD reps, inc the accumulator, store back in reps, is reps equals 6, so CMP 6, and repeat the next value, jump, and we want to jump to a loop, and we want to loop from here. Makes sense. Loads the next value. So it'll load that one, then it'll load that one, then that one, then that one, etc. Okay, so this is going to require another bit of skill. So to start off with, we're not given any much information at all. But what we do know is that we want to take number 1 and turn it into 2's complement form and store the result in number 2. So the first thing we want to do is load up number 1. So I'm going to do LDD number 1. And what we want to do now is convert it into 1's complement. So we've got 0, 0, 0, 0. So that's 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8. Now, to turn this into 1's complement, we flip them. So we know that that'll be 1, 1, 1, 1, 1, 0, 1, 0. But in order for this to basically work, we need to use a mask. And this mask will be a type of logic gate. It's going to be a bitwise operator, basically. So if we were to use an AND in this situation, so this is the number we need to get to, the 1, 1, 1, 1, 1, 0, 1, 0. I'm just going to erase this for a second. And I'm going to put it down here. So we want to 1, 1, 1, 1, 1, 0, 1, 0. But we need to work out a way of how we can force this to turn to this. So that's where we're going to use a mask value. And by default, we're going to use a mask of 1, 1, 1, 1, 1, 1, 1, 1, because we want to affect, or potentially affect, every single bit. So if we were to do 1, 1, 1, 1, 1, 1, and this is like a go-to if we were going to do this for 2's complement, because we do want to affect every single bit, so this is going to be 1, 1, 1, 1, 1, 1, 1 every time. If we're going to use AND, 1 and 0 gives you 0. 1 and 0 gives you 0. So unfortunately, we haven't actually flipped these around. These should be 1s, so AND won't work. So what about if we used OR? So hold on, let me just put the mask in here of 1, 1, 1, 1, 1, 1, 1, 1. That should be 8 ones. 1, 2, 3, 4, 5, 6, 7, 8. Okay, cool. So if we used OR, let's try it this way. 1 or 1 gives you 1. 1 or 1 gives you 1. 1 or 1 gives you 1. So already we've seen this is not going to work, because this should be a 0 because that was a 1. It should be a 1, that's fine. This also should be a 0. So we failed with using OR as our mask. Sorry, as our bitwise operator. So let's try NAND. 1 NAND 1 gives you 0. So that flips it. 0 NAND 1 gives you 1. So it's flipped it. So it's working so far. 1 NAND 1 gives you 0. So it's flipped it. 0 NAND 1 gives you 1. 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 And we've got 0 NAND 1 gives you 1. So we've got 1, 1, 1, 1, 0, 1, 0. So that has actually worked. And whilst I did say that 1, 1, 1, 1, 1, 1, 1 is going to be the most likely mask we're going to use because it affects every bit, NAND won't work if we were to use a different mask, which we might get given by the exam board at certain points. So whilst it's working for this, the one we're going to be going towards is actually XOR. So if we did XOR operations on this, 1 XOR 1 gives you 0. This will give you a 1, 0, 1, 1, 1, 1, 1. So it gives you the same result. So XOR is normally what we use when we're using 2's complement. So, well, to put it into 1's complement first, shall I say. So going back to this, I'm going to XOR our mask. Once we've XORed the mask, what we're going to need to do now is turn it into 2's complement, because we're not there yet. We've turned it into 1's complement, we flipped it. The next thing we need to do is add 1. So to do that, we simply increment the accumulator, because this will be in our accumulator. this value. By us incrementing the accumulator, we're going to make it go up by 1. So lo and behold, what we're going to have now, once we do the calculation, we're going to store it, and we're going to put it back into, but this time we're going to put it into number 2, the 2's complement version. So we're going to have 1, 1, 0, 1, 1, 1, 1, 1. So that should be in here, binary 1, 1, 1, 1, 1, 0, 1, 1. And there we go. That is done. That is us using 2's complement. Step 1, we zeroed it, the mask, to flip it. We then incremented the accumulator by 1, so we added 1. That's how we do 2's complement. We then did our calculation, we stored it into number 2, and we end.